Section 13.5, Application Management and Monitoring with Spring Boot Actuator. In the previous sections, I've shown you the primary telemetry data that all cloud-native applications should provide to achieve better observability. This final section will be dedicated to some specific information you can retrieve from applications to further enhance what you can infer about their operations. Spring Boot Actuator provides many features to make your applications production-ready. You have already learned about health and metrics endpoints, but there are more. Table 13.1 lists some of the most useful management and monitoring endpoints implemented by Actuator. This section will show you how to use some of them.
Table 13.1. Some of the most useful management and monitoring endpoints exposed by Spring Boot Actuator. View table figure.
Section 13.5.1, Monitoring Flyway Migrations in Spring Boot. In Chapters 5 and 8, you saw how to version control your database schemas using Flyway migrations and integrate them with Spring Boot, both in imperative and reactive stacks. Flyway keeps the history of all the migrations run on the application in a dedicated table in the database. It would be convenient to extract such information and monitor it, so you could be alerted if any migration should fail. Spring Boot Actuator provides a dedicated endpoint, /actuator/flyway, to display information about all the migrations run by Flyway, including their status, date, type, and version. As you learned in the previous sections, you can enable new HTTP endpoints to be implemented by Actuator through the management.endpoints.web.exposure.include property. Let's see that in action. Note: if you use Liquibase instead of Flyway, Spring Boot Actuator provides an /actuator/Liquibase endpoint. Open the Catalog Service project, Catalog Service, go to the application.yml file, and configure the Flyway endpoint to be exposed over HTTP by Spring Boot Actuator.
Listing 13.23, Exposing the Flyway Actuator endpoint.
Then run the backing services required by Catalog Service as a container. From your Docker Compose file, execute the following command.
See this code.
Next, run catalog service /gradle wbootrun and call the Flyway endpoint.
See this code.
The result is a JSON file containing the list of all migrations run by Flyway and their details. The following snippet shows an extract of the complete response.
See this code.
Section 13.5.2, Exposing Application Information. Among all the endpoints implemented by Spring Boot Actuator, /actuator/info is the most peculiar one, since it doesn't return any data. Instead, it's up to you to define what data you consider useful. One way to contribute data for the endpoint is through configuration properties. For example, go to your Catalog Service project, Catalog Service. Open the application.yml file and add the following property to include the name of the system of which Catalog Service is part. You'll also need to enable the info endpoint to be exposed through HTTP, similar to what we did with the other endpoints, and enable the NV contributor responsible for parsing all the properties with the info prefix.
Listing 13.24, Exposing and configuring the info actuator endpoint.
You can also include information that's generated automatically by Gradle or Maven regarding the application build or the last Git commit. Let's see how we can add details about the application's build configuration. In your Catalog Service project, go to the build.gradle file and configure the Spring Boot task to generate build information that will be parsed into a build properties object and included in the result from the info endpoint.
Listing 13.25, Configuring Spring Boot to include build information.
Let's test it out. Rerun Catalog Service /gradle wbootrun, then invoke the info endpoint.
See this code?
The result will be a JSON object containing build information and the custom info.system property we defined explicitly.
See this code.
You can expose additional information about the operating system and the Java version in use. Both can be enabled via configuration properties. Let's update the application.yml file for the Catalog Service project as follows.
Listing 13.26, Adding Java and OS details to the info actuator endpoint.
Let's test it out. Rerun catalog service /gradle boot run, then invoke the info endpoint.
See this code.
The result now includes additional information about the Java version and operating system in use, which will be different depending on where you run the application.
See this code.
Section 13.5.3, Generating and Analyzing Heap Dumps. Among the most annoying errors to debug in Java applications, memory leaks are probably the first that come to mind. Monitoring tools should alert you when a memory leak pattern is detected, usually inferred if the JVM heap usage metric keeps increasing over time. If you don't catch the memory leak in advance, the application will throw the dreaded out-of-memory error and crash. Once you suspect an application might suffer from a memory leak, you must find out which objects are held in memory and block the garbage collection. There are different ways to proceed with finding problematic objects. For example, you could enable the Java Flight Recorder or attach a profiler like JProfiler to the running application. Another way is to take a snapshot of all the Java objects in the JVM heap memory, a heap dump, and analyze it with a specialized tool to find the root cause of the memory leak. Spring Boot Actuator provides a convenient endpoint, /actuator/heap dump, that you can call to generate a heap dump. Let's see that in action. Go to your catalog service project, catalog service, open the application.yml file, and configure Actuator to expose the heap dump endpoint.
Listing 13.27, Exposing the Heap Dump Actuator Endpoint.
Next, build and run catalog service /gradle boot run. Finally, invoke the heap dump endpoint.
See this code.
The command will save a heapdump.bin file in the current directory. You can then open it in a dedicated tool for heap analysis like Visual VM, visualvm.github.io, or JDK Mission Control. See this link. Figure 13.10 shows an example of heap analysis in Visual VM.
Figure 13.10. Visual VM provides tools to analyze a Java application's heap dump.
Finally, stop the application process, Control-C, and all containers, Docker Compose down. I encourage you to check out the Spring Boot Actuator official documentation, try out all the supported endpoints, and make the applications of the Polar Bookshop system more observable. For inspiration, refer to the source code repository accompanying the book to see which endpoints I have enabled on each application. Chapter 13/13end. They're powerful tools that you'll likely find helpful and convenient in real-world applications running in production.